Now let's try to reverse the given singly linked list problem. So whatever it may be, when it comes to data structures and algorithms, one of the very much overhyped problem is reversing the given singly linked list. It is not difficult or whatsoever, just because of all the memes and all the jokes that you've been seeing on the social media. It kind of gives you a feeling that it is very much difficult to solve, but it is not at all difficult. Just try to follow the algorithm that I'm going to explain. You will never ever forget it. Okay, so that being said, let's just try to understand. You will be given an input list with some values in it. You have to reverse the given singly linked list and try to do it in the same place. That means that try to not use any additional memory in reversing process. Okay, so remember that here we will be given the head node of the singly linked list. Any node of the singly linked list will have the value as well as pointer to the next node, which is nothing but next. So that is the structure of the singly linked list node that we will be following as well. It will have value, it will have the reference of the next node in the variable name next. Now here, this is the input list that we have gotten. If at all, after reversing the given singly linked list, the output should be reversed. That means 1, 2, 3, 4, 5 are the values that we have in the singly linked list before reversing, and after reversing, obviously the output should be 5, 4, 3, 2, 1. Similarly here, these are the values in the input list and these are the values in the output list. And ultimately here, remember that input list might contain duplicates, or it might contain heterogeneous data or anything. The reason why I have mentioned this point inside the problem statement is that usually singly linked lists are usually most of the data structures are heterogeneous data structures, right? That means that they can hold any type of data in them. So that is the reason why here I have mentioned this. But nonetheless, even if your problem statement doesn't mention, you can obviously assume that singly linked list can have heterogeneous data, but it is completely up to the problem statement that I have defined here. Nothing to worry about that specific condition. And input list can be empty as well. Okay, so that is the problem statement that we have gotten. Now we need to write the effective logic for reversing the given singly linked list in place. Remember that here we have gotten a singly linked list head node. That means we can read the values that we have in every node of the singly linked list, and again we can construct the reverse singly linked list as well. But that is not the way we have to approach this problem, because the problem statement said that we have to do it in place. That means by just readjusting the nodes that we've gotten in the singly linked list, we should be able to reverse it in place. Okay, that is the problem statement. Now let's dive into how can we reverse it. Alright, so here the list that we have gotten has the values 1, 1, 2, 3, 4, 5. So if we represent it in the pictorial form of the singly linked list, this is how it is going to look. And here every node will have two variables in it. One is value and the other one is pointer to the next node in the variable next. Now we need to reverse it. For this, what we will do is we will define three variables. One is current node. In the beginning, it will be pointing to the head node that we have gotten, which is nothing but 1 that we will be getting in the function argument. Similarly, what we will do is we will define another variable called next node. This also in the beginning, it will be pointing to the head node as well. Along with that, we will define one variable called reversed list. This will hold the reference of the head node of the reversed singly linked list at any given point of time. Remember that this reversed list variable will basically hold the head node of the reversed linked list at till that point of time. In the beginning, there is no head node, right? That means that we haven't reversed anything. So here we will be initializing it with null. In most of the programming languages, we will initialize it with null. In Python specific implementation, we will be initializing it with none. Now what we will do is, as long as we have not reached the tail node, that means that whatever the current node that we have is not equal to end. How we will know? We will compare it with null. In Python, we compare it with none. So we will simply run a loop. What we will do? We will go on to the current node. So current node right now is not null, it is at 1. So what we will do is pick up the node that we are at, and this needs to be reversed, right? That means whatever the reverse list that we have so far, it will be pointing to the, it will have the reference of the head node of the reverse linked list till that point of time. So whatever the node that we pick up, it should come before, so that in the end we will have all the reversed values. So whatever the node that we pick up, what we will do, current node dot next that we have, we will be updating it with the reverse. So far it is having null, so it will have added 1 right now. Immediately we will have next nodes also, right? So we will update the next node with the current node dot next. It will be pointing to this one. Now also current node is not null, we still not have reached the end. What we will do, this is the reversed so far. So we will pick up 1 again, and 1 we will add in the front of the reversed list that we have so far. That means this current node dot next, which is 1 dot next, we will assign with reverse. As a result, the 1 will get added in the front, and the reverse list will be having this 1 in it. Immediately next is again having 2, we will pick it up, and 2, what we will do, current node dot next is equal to reversed. So this reversed will be having 1, we will add 2 here. Similarly we will move on to the node 3, and 3 will get added here. Immediately we will move on to the next node, we will add 4 here, and immediately we will move on to the next node 5, and we will add it here. Once we reach 5, current node dot next will become null, and we no longer have nodes to add. So here the final reversed linked list is nothing but 5 4 3 2 1 1. If you see 1 1 2 3 4 5 is what we have. If we reverse, 5 4 3 2 1 1 is what we have gotten. Remember that we will run the loop till we reach the very last node that we have. Basically the current node will become null or none. In the case of Python it will be none. In the case of any other programming language it will be null. So every time we pick up the node, this reversed list will have the head of the reversed linked list so far. So whatever the node that we pick up will get added in the front. That means the current node that we pick up dot next should be added with this reversed list so far. In the end, reversed we update with the current node that we are at. Okay, so that is the logic. Now let's try to do the same thing on one more singly linked list. Let's just say we have a singly linked list containing hi, bye, see you. So immediately we will start here, and this reverse list in the beginning, it will be null in most of the programming languages, none in the beginning. So we will pick up the node, and the head of the reverse list so far is null. So we pick up the node and we add the next to it. So hi dot next will be none anyway, and we will move on to the next. Okay, we will pick up by, this by will get added again, and then we will move on to the next node see you, and we will add it here. So see you by hi is the reversed list. We don't have any more nodes left here to pick up and process. Okay, very simple implementation. Just the point that you need to remember here is we will have 3 variables. Current node, it will point to the current node that we are processing. Next node is something that will help in keeping track of the next nodes that we can process, because current node dot next we are updating with reverse, right? So if we don't keep track of the next nodes in some variable, there is a chance that we might lose the track of that. That is the reason why we have here the next node variable. Okay, that being said, let's just quickly go ahead and write the pseudocode of it, and later let's try to write the programmatic implementation and validate various scenarios. Alright, now let's try to write the pseudocode. So here we will have one function called reverse singly linked list, and what it does, it will take the head node. Immediately, there is a chance that there is no node itself in the given head, right? So that means if the head node is equal to null or none, So this none check is for the Python specific learners and this null is for all other programming language specific learners. So here, if this is the case, we did not have a valid node reference inside this head. So immediately we can't reference it, we can't return, reverse it anyway. So we can return that null or none itself back to the user. If this is not the case, like I mentioned, what we will do, we will define three variables: current node, it will be pointing to the head. Similarly, we will define another variable called next node. It will be pointing to the head node itself in the beginning. Along with that, we will define one variable called reversed. This will hold the head of the reverse singly linked list till that point of time. In the end, that is what we need to return. Because if we have the access to the head node, using the next reference, we will be able to reach the end of the singly linked list as well. So here, in the beginning, it will be pointing to a empty value, which is nothing but null, or in the case of Python, it will be none. Now what we will do, as long as this current node that we have is not equal to null or none, in this case, what we will do, we still have some nodes to process. We need to pick up all those nodes and we need to construct a reverse singly linked list out of that. For that, immediately what we will do is, whatever the next nodes that we have, this will be current node dot next, right? So we will read and keep it in one variable. Now this reverse list has head reference of the reverse linked list till that point of time. Now it needs to get added on the next of the current node that we are processing. So current node dot next is equal to the reverse list. Now the head of the reverse list is nothing but whatever the current nodes that we are processing. Later on, whatever the node that we pick up, it should get added in front of that. That is the reason why here reverse we will update with the current node. That is done so far. Now the node that need to get processed in the later iteration is there inside this next node variable, but our loop is running on the reference of the current node. So we will simply update the current node with the next node so that it can run the next iteration. Once this is done, all the nodes that we get will get added on the reverse direction and we can simply return the reverse list reference itself because it has the reference of the reverse linked list head node. That itself helps us in reading all the values, so we can return that. Okay, so that is the simplest implementation of the reversal of a singly linked list in place. So if we want to analyze the time complexity of this specific algorithm, obviously from very first node till the very last node we had to go. That is the reason why this while loop, whatever we have, will run for n number of times. As a result, the time complexity will be order of n. And the space complexity, if you see, we are not creating any list or whatsoever. With the simple couple of variables itself, we are constructing the reverse singly linked list in the same place. That is the reason why the memory consumed will also be constant, which is nothing but order of 1. Okay, so that is the pseudocode for the overhyped reversal of the singly linked list. Now let's quickly write the C++ implementation of it as well. Now since it is our first singly linked list specific practice problem, inside the singly linked list folder where we are writing all our singly linked list specific implementation, I have created a new folder called practice. Inside that folder I have added a new file called reverse as singly linked list.cpp. Okay, one thing that you need to observe here, since we need to pass the head node of the singly linked list, which we will be reversing and returning in the end, I have also added the singly linked list header file that I have created as well. Okay, just see this. This is very important because when we want to pass and when we want to construct a singly linked list and pass that specific head node, we will be simply reusing the singly linked list implementation that we have already done. Okay, that's the reason why the import statement is also related to the whatever the folder structure that I have here. If at all, if you are writing the solutions in different folder structure, you just need to modify it accordingly. Okay, that is the organization of the practice files. Now if you see here in this file, I have added the new class for reversing of a singly linked list. Along with that, I have also added the function declaration for reversing of singly linked list. If you observe here, I am taking a singly linked list nodes or the head node which basically contains all the integers only. That's the reason why here I have passed integer. If at all if you want to test out the singly linked list reversal in a string, you just need to modify it accordingly, so that in the end we need to return the singly linked list which is reversed, right? The reverse singly linked list will also have the similar values as that of input. That's the reason why here the return type is also exactly same. Here for better naming conventions, we will be taking the head node, right? So let's just read it into head, and let me just remove this. Okay, for now, if you see here the main method, I have created the object of singly linked list, and I have basically passed integer itself, because all the values in the singly linked list will be of integer only. So that is something that you need to observe here. Along with that, I have created the object of our class and called the function, and here I have written the traversal of whatever the reverse singly linked list head node that we will be getting, right? We would want to see the values that we are getting after the reversal. So I have basically written the traversal of the singly linked list head node, using head node as well. So this logic is exactly similar to whatever the traversal logic that we have written in the case of singly linked list. Okay, now that this is clear, let's just deep dive into the implementation. So here, as part of the first step, what we will be doing, we will basically write couple of helper variables, right? So let's just define those helper variables. So in the beginning, let's just define one variable called current node. This current node variable will basically keep track of the current node that we need to process. So in the beginning, this is nothing but head node. Along with this, let's also define another variable next node. Okay, this will basically represent the next nodes that we need to process. In the beginning, this also I am going to initialize it with head itself. Along with that, to keep track of the reverse singly linked list, what I want to do is I want to define one variable reversed, and this in the beginning I will be initializing it with null. Remember that whatever the reversed variable that we are maintaining, this variable will basically represent the head node of the reversed singly linked list so far. Okay, that is very important. Since in the beginning there are no nodes that we have processed, the head node will be pointing to null, right? That's the reason why here I have initialized it with null. Okay, now we will be running a loop while as long as whatever the current node that we have is not equal to null. That means that we still have some nodes that are unprocessed, so we need to process them and reverse those nodes as well. Here, as part of the while loop, the very first step is we need to update the next nodes that we will be processing, so that we will not be losing the track of them. So whatever the next node variable that we have, we will be updating it with current node dot next. Okay, once we have that, we have the next nodes. Now whatever the current node that we have, this we need to reverse. So far whatever the reverse singly linked list is there, that is available inside this reversed, right? All we need to do is whatever the current node that we have, to this next we will assign whatever the reversed that we have so far. So here current node dot next is equal to whatever the reversed list that we have so far. This reversed will basically hold the head node or very first node of a reverse singly linked list, right? So it is completely fine. Now the modified reversed singly linked list head node or the first node is nothing but the current node that we have here. So let's just update the entire reversed is nothing but whatever the current node that we have here. Okay, in the end the nodes that we need to process here is nothing but this next node, right? So let's just update the current node is equal to next node, so that our loop will continue and it keeps on adding the values in the reversed fashion. Okay, in the end, once we are done with processing of all the nodes that we have in the singly linked list, we would be returning the head node or the first node of a reverse singly linked list, right? That is nothing but this reversed itself. So here let's just return reversed directly. Okay, very simple implementation. just you need to remember the process so that you will be able to write the logic. First you need to keep track of the next nodes, and after that whatever the current node that we are processing, to that next we will assign the so far reversed singly linked list, and ultimately the reverse singly linked list is increasing. That is nothing but whatever the current node that we have so far, that will represent the reverse, and in the end, to continue with the next node's reference, we will simply update the current node with next node that we have got. Okay, so that is the purpose of next node variable that we are keeping track here. Okay, so that is the implementation, right? Now let's just, anyway we have written the code for calling of that function as well. If you observe here, the singly linked list constructor that I have done here is basically holding the integer values. That's the reason why all the logic that I have written here also is of type integer. Okay, if you are trying it in some other coding platforms or somewhere, you just don't need to pass this. Since I am going to reuse the singly linked list implementation, that's the reason why I have written the code in this format. Okay, you just need to align with the platform that you are trying to solve this problem in. Okay, now anyway, in the singly linked list that I have created, I have passed 10, 20 and 30. Okay, and I have created the object of reverse singly linked list and called the function by passing the head node of the singly linked list. Now we are getting the reversed singly linked list head node, right? In the end we simply traversed and we are printing it. Okay, now if you observe here, the singly linked list that I have created here has 10, 20 and 30. So if I run this code right now, ideally the reverse singly linked list should contain 30, 20 and 10. So if I run this, let's see what is the output. See, the output is 30, 20 and 10. Let's just say I have few more values. Let's just say I have inserted 20 once again. Now if I reverse this, output should be 20, 30, 20 and 10. So if I run this now, let's see 20, 30, 20 and 10 is what we have gotten, which is nothing but reversing of whatever we have here. Okay, so along with this, let's just try to test one scenario where there are only two values. So right now two values are 10, 20. So if I reverse this, 20 and 10 should be the output. So see, that is what we have got. Let's just say we have only one value, 10 itself we have. So ideally the reversed will also have only 10. So 10 is what we have got. Let's just say there are no values at all in the singly linked list. In that case, obviously the reversed linked list will also not have any values. So if I run this, output should be empty. Okay, so whatever the logic that we have written for reversing of singly linked list is working fine for all the scenarios of a singly linked list. Okay, so that is what the entire C++ implementation is all about. Okay, things you need to remember here is, since I am passing the singly linked list which has only integer values, here I am taking it this way. That's the reason why here all the variables that I am defining also has this specific type. So maybe based on the platform that you are trying to validate this solution in, you may need to remove this type validation whatever we have here. Okay, so that's it for this one. If even after this, if you have any doubt, you can go to codingpal.org visualization panel and you can visualize the problem in real time and see what exactly is happening in each and every step using the problem link in the description box. Okay, so that's it for reversing of singly linked list. I'll see you in the next problem.